Alright, so we're going to be looking at 3 different jobs. The first one is a salary position making $40,550 per year. The second job is hourly, making $19.45 an hour, assuming 5 8-hour days for 52 weeks per year. And the last job is 3.2% commission with an average of $105,500 per month. For each of the jobs, it's going to be $300 a month for health insurance and 3% of your gross income for retirement. Assume you get 5 days paid off, but you end up taking 15 days. So that means you're going to have 10 unpaid. So we're going to work through this the same way that we did for our assessment. So for the first one, this is a salary position. So the only calculations I need to do is account for those 10 unpaid days. So I'm going to take my $40,550 and divide by 260 because that is the normal amount of work days in a year. 40,550 divided by 260. So I'm making about $155 per day. I need to multiply this by 10 because there are 10 unpaid days. So I am losing this amount from my income. So I'm going to take what I thought I was making, which is the $40,550, and subtract this $1,559. So that leaves me with a gross annual income of $38,990.38. The next thing is to find your adjusted gross income. This is where we take into account our benefits. Okay, so the benefits that we have is $300 a month, so 300 times 12, which equals $3,600 for health insurance, and then 3%, so 0.03 of our gross annual income, which is the $38,990. So I take this number times 0.03, 1169.71. So I have to pay both of these. So I take this, I'm going to subtract my retirement, and then subtract $3,600 for my health insurance. And that leaves me with an AGI of $34,220.67. We can't forget about our FICA taxes. This is 0.0765 of our gross annual income, not our AGI. So make sure you're going back and looking at the gross. So I take 0.0765 times that 38,990. So I'm going to have to end up paying $2,982.76 for my FICA taxes. Now, to calculate my income taxes, I have to know my taxable income. So the formula for this is your AGI minus the $13,850, which is our standard deduction. It's always going to be the $13,850. So I take my AGI, which is the $34,000, and I subtract $13,850. So my taxable income is $20,370.67. The only thing that we use this for is to find the amount for income taxes. So this is where you pull up your tax table, and we're looking for $20,370. $20,370. It's going to be between here. So $2,200 is how much I owe in income taxes. So to get my take-home annual income, I am going to take my AGI, subtract my FICA taxes, and subtract my federal income taxes. So this $34,000 minus this $2,900 minus the $2,225 that I found from the chart. So I'm actually taking home $29,012.91. To make that monthly, you just divide by 12. $2,417.74. Alright, let's look at another position. So this one is hourly. So for hourly, we first have to calculate what our income is. So I am making $19.45, 8 hours a day, 5 days a week, and I'm taking 10 unpaid days. This is the equivalent of 2 weeks. So really, I'm only going to get paid for 50 weeks. Number of weeks paid. Okay, so if I multiply these together, 19.45 times 5 times 8 times 50, I get $38,900. Okay, then we need to account for our benefits. So same as the last time, it's $300 a month, so $3,600 for health insurance, and then 3% of this $38,900, so 1,167. So I'm going to subtract both of those. So I take my $38,900 minus $3,600 minus the $1,167, and I get $34,133 as my AGI. Now take care of our FICA taxes. That's 0.0765 times this number right here, your gross income, not your AGI. So I'm going to have to pay $2,975.85 for for my FICA taxes. To find my taxable income, I take my AGI, which is this $34,133, and I subtract the $13,850. That's my standard deduction. So my taxable income is $20,283. Now remember, we are only using this on the tax table. So I'm looking for $20,283. $20,283 is 2213 in federal income taxes. To figure out my take-home salary, I take my AGI minus my FICA taxes minus my federal income taxes. So $38,900 minus this $2,975 minus $2,213 from the tax table, and I am bringing home, I think I typed something in wrong. Yep, I did. So it's this $34,133 minus the $2,975.85 minus the $2,213. 2,894.15. And then the last step, divide it by 12. So each month I am bringing home $2,412.01. You're rounding based off normal rounding, because that's okay. This last job is commission. So for commission, we have to calculate first the income. So it's going to be 0.032% of $105,500 a month, so times 12. So 0.032 times 105,500 times 12. So I'm making $40,512, but I have to account for 10 unpaid days. So I'm going to find my daily rate, multiply by my 10 to account for my 10 missed days, and subtract that out. So I thought I was making this amount minus my 10 days of unpaid. So my gross annual income is actually $38,953.85. Okay, then we account for our benefits. So it's still $300 a month, which is $3,600 a year, and 3% that gross income. Okay, so I'm going to take that gross income minus my $3,600 minus this amount, and my AGI is 34185.23. I'm going to account for my FICA taxes. So it's 0.0765 of my gross annual income. Make sure you're using the whole decimal. So the 38953 times 0.0765. So I have to pay $2,979.97 in FICA taxes. To find my taxable income, I take my AGI, which was this 34, minus the 13,850, and I get 20335.23. The only thing I'm using this for is on the tax table. So I go in and look at 20,335. It's going to fall between here, so 2219. So my last step is my take-home annual income. I take my AGI minus my FICA minus my federal income taxes. So I'm taking home $28,986.26. To make that monthly, you simply divide by 12. For $2,415.52 a month. So that covers all of our income rows. Now let's talk about investments. So the first one we have is a savings account that you are investing $1,850, and the savings account is 2.75% interest compounded annually. Alright, and then the other one is a CD that pays 3.25% simple annual interest. So I'm going to start with my equations first, which is down here in this X column. So to find the ending balance, it's Y equals, I'm starting with 1850, 1 plus, to change 2.75, you divide by 100, so it's 0.0275, compounded annually, so that's divided by 1 to the 1 power, and then X is my time. For my CD, which is simple interest, to find my ending balance, it's going to be the 1850 times 0.0325, that's my interest rate, times the time. This would be my formula for interest, but we'll have to add back the 1850 if we want to know the ending balance. So if I plug these into my calculator, my Y equals 1850, 1 plus 0.0275 divided by 1 to the 1x, and then 1850 times 0.0325 x plus 1850, and I hit second graph, I can see for every single period. So at the very beginning 1850, at the very beginning 1850. Then after 1 year, 1900.88. After 2 years, I have 1953.15, 2006.86, 2062.05, $2,118.76. Notice that I'm actually hovering over it to get the exact decimal. Okay, for my other account, after 1 year, I have 1910.13, then I have 1970.25, then I have 2030.38, 2090.5, 2150.63. And I could do that for any year and find out what my ending balance would be. But don't forget to add back that initial deposit if it's simple interest. So which investment is the best choice for Layla? So if you're looking at these, you can see that this one has a higher ending balance. But eventually, because this is compound interest, this is going to pass this one up. So it really depends on how long she plans on keeping it in the account. So let's see, when does my first one become more? 2632. So if she's going to keep it in longer than 13 years, the savings account is better. Otherwise, using the CD would be better. Jack uses this equation to calculate his savings balance. Okay, so I can see that this is very similar to this equation right up here. So the initial investment is that first number, so that's the $2,900. The interest rate is 1 plus the interest rate. So here, if I was to take 1 plus x equals 1.0395, to figure out what my interest rate is, it's going to just subtract 1. So it comes out to 0.0395, which as a percent is 3.95%. What is his balance after 1 year, 2 years, 10 years? So same thing, I'm going to plug this in my calculator. 2,900 times 1.0395 to the x. And this would be compounded annually because whatever you divide by also goes up here, and there's an invisible 1 in front. So second graph, his balance after 1 year is 3014.55. After 2 years, it would be 3133.62. After 10 years, it would be 4272.11. Is this simple or compound interest? So because the x exponent, it has to be compound interest. Alright, these are like those equations where you just have to solve for the unknown. So Luis earned $2,400 at his summer job. He deposited this money into an account that pays 2.5% interest, so this is my I, compounded quarterly. This means n equals 4. How much money will he have? So it's asking for the future value when your t is 3. And this is how much he's depositing, so that's my present value. So FV equals 2,400, 1 plus, to change this to a percent, divide by, or a decimal, divide by 100. So 0.025 divided by 4 to the 4 times 3. There's no exponents over here, so you can just plug that in your home screen. So my future value is going to be 2586.32. Olivia is 20 years old and wants to save $2 million for retirement in 60 years. So this is the future value. Retirement in 60 years, that's your time. Assume she invests in a savings account that earns 6.8%, so that's your I, compounded annually, means n equals 1. What should she invest today? So we're solving for the present value. So 2 million, 2, 1, 2, 3, 4, 5, 6 equals x, that's my present value, it's unknown, 1 plus, my interest rate would be 0.068, just divide by 100, divided by 1, to the 1 times 60. This time we're solving for the present value, so our step is going to be divide by this entire parentheses. So I'm going to do alpha y equals, to be able to make sure my order of operations is correct, 1, 2, 3, 4, 5, 6, parentheses, 1 plus 0.068 divided by 1 to the 1 times 60. So she needs to deposit $38,614.90. This one you have to round up. Because if I only deposited 89 cents, I wouldn't quite meet my goal of $2 million. So I have to do the 90 cents. Leslie wants to invest, so that means this is the present value, into an account that earns 7.25, that's my rate, and it's simple interest. Money is withdrawn and if no money is withdrawn and no deposits are made, how much will be in Leslie's account after 8 years or 12 years? Okay, so it wants to know the balance. So this is the future value. So the future value for simple interest is PRT plus P. So to find the future value, I'm going to take this 3250 times 0.0725 times 8 plus the 3250. To figure out in 12 years, I'm going to do the same thing, the 3250 times 0.0725, but this time times 12 years. 3250 times 0.0725 times 8 plus the 3250. So this is how much I have after 8 years. I go and I keep this, but just change this to 12 years. That is my future balance. All right, Abigail wants to invest, so this is your present value, in an account that earns 4.75% compounded monthly, so n equals 12. What will be the future value in 36 years? That's my time. What if it's compounded daily? If n equals 360. All right, so to find future value, we take this 7882 parentheses 1 plus 0.0474 divided by 12 to the 12 times 36. Now if we were to do it daily, it would be the 7882 1 plus 0.0474 divided by 360 to the 360. Whatever number is down here also goes up here, and then times 36 years. All right, so if we plug both of these in, 7882 parentheses 1 plus 0.047 divided by 12 to the 12 times 36, the future value is 42,660.64. If it's compounded daily, and we change this number to be 360, and this number to be 360, but everything else stays the same, it is 42797.14. So you can see that compounding daily makes you a little bit more, but not a whole lot more. Benjamin wants to have $225,000, so this is the future value, in 12 years, that's your time, and investing in an account that earns 0.38%, that's your I, compounded quarterly, n equals 4. How much does he need for his principal investment? How much will he need if he finds an interest rate of 5%? So for my first one, I want to have 225,000 equals, we're solving for the principal, 1 plus 0.0038. Divide by 100 if you struggle with converting it to a decimal. It is compounded quarterly, so divided by 4, and then 4 to the 12 years. To solve for x, you simply divide by this entire parentheses. So alpha y equals enter on top 22500 0 on the bottom parentheses 1 plus 0.0038 divided by 4 to the 48. So he needs to deposit $214,975.07. You have to round it up. Okay, so let's see if instead he found a rate with 5%. So this time it would be the same, except my rate here would be 0.05. Again, you have to round up. So you can see it's almost half of what we had to have if we can find a better interest rate. 14,000, so that's your present value, grows to be 64,000 in the future in 20 years. What is the interest rate if it's compounded, so n equals 12? How about if n equals 4? So 64,000 equals 14,000, parentheses 1 plus, we're solving for the interest rate, over 12 to the 12 times 20. Alright, so this is where it's important to have your list of steps. So your first step is going to be divide by the present value. So I'm going to take this 64,000 and divide by 14,000. And I get 4.57 equals this. Now if this was a squared, you would square root it. So you're going to do the same thing, except you're taking the 240th root of this number. So you hit math 5, and we're taking the 240th root of that entire decimal. So you're taking the n times t root. Okay, so I get 1.00635 equals 1 plus x over 12. Your third step is we're going to subtract the 1. So minus 1. And then your fourth step is multiply by n. So in this case, multiply by 12. Multiply by 100 to change it to percent, and it is 7.63%. This is one where you would have to round up. Otherwise, you won't have the 64,000. Now it also asked, what about if our n was 4? So we're going to do the same steps. We divided, right? But now we are going to take the math 5, the root of 4 times 20 years of this entire decimal. Then we divided, we took the nth root, we're going to subtract 1, and then multiply by n, which is 4. Multiply by 100 to get a decimal, and we get 7.68%. Again, make sure you always round up. Often advertise an APR, and this is going to be your APY formula. APY equals 1 plus I over n to the n minus 1. So they're telling us our APR is 19.75, and it's compounded daily, and we'll use 360. So we get 1 plus 0.1975, you just divide it by 100, divided by 360 to the 360 minus 1. 1 plus 0.1975 divided by 360 360 to the 360 minus 1. Multiply by 100 to change it to a percent, and you get 21.83%. Your APY should be bigger but close to your APR. So what about if it was compounded monthly? This is the 1 plus 0.1975 divided by 12 to the 12 minus 1. So 1 plus 0.1975 divided by 12 to the 12 minus 1. Multiply by 100 to get a percent, and it's 12.64%. So the more often it's compounded, the more interest you're actually going to end up earning.